Hey, hey. I'm wondering if one of you would be willing to give me a volume check so I can make sure that I can hear.
Yeah, I can hear you.
We can hear you, Kale.
Love it. That's a win. Okay, so we're at a good place, I think, at least technology wise. It's working. I'm in a physically different location than I've ever done class before, and I'm happy. It's going. Okay, so what I want to do is to just start the normal way by doing a share screen. And then we'll proceed in the normal way, which is like you ask any questions anytime, and I'm going to try and highlight the things that I think matter the most, that are most likely to have questions, and we'll see where we get to. So first thing is, I think I mentioned yesterday, done grading the exams. Y'all did pretty good. Happy, yay. Next exam will be on newish material, whereas the first exam, a lot of it was on material that could be thought of as review. Not surprising. That's sort of the nature of these second term stat classes. We start with review of the stuff that you should know, because sometimes when you get only one stat class, there's this goal to put a lot of certain topics in. And so we're making sure you're all on the same page before we move forward. And according to the midterm, you all were on that page. Good. I guess where we're at then is since then we've finished up chapter 4, where the real key question is if you got two variables or three or four explanatory variables, can we put them in a model? And the answer was, well, because we did a general linear model, yes, you can. And then chapter 5 is like, well, what if you have entirely categorical factors and you're trying to design an experiment to answer a question? It felt pretty good. Chapter 6 and 7 are, if you will, the heart of the matter, the central part. Actually, I guess technically we're right at the middle of the term. But chapter 6 is where we start to talk about combining categorical and quantitative variables together in one analysis. Now, you sort of thought, well, we already did that. And the answer is, yeah, we did. But we're going to get into the way the model works today. And then we're going to talk about the next natural question tomorrow and then Thursday. So let's actually go back because I'm not sure I'm remembering everything. Let's look at the midterm, the syllabus in terms of when would the next midterm exam be? Yeah, we're right on task. We're on, chapter 7. We're going to spend 2 days on chapter 7. Maybe a little bit more than in a regular term, but because it's summer, yeah, and we're going super fast, in my opinion. And because this is a topic which deserves being careful and going through carefully and slowly, 2 full days on that. And then finally, before the exam next Tuesday, we'll talk about this partial F test. And I guess a week from tomorrow is when we're going to release the exam into the wild. And then you need to have it done by the 17th, I believe, 13th. Yeah, the 17th. Okay. Let me sort of close that up so we can see where we're at. And let me make this such that, okay, well, I wanted to see more of y'all. Okay, so, okay. I get to see some, but not all of what I wanted to see. It's this other, you know how Zoom puts stuff like right in front of you and you can't like move it off to the side completely? That's my life today. Okay, so any questions that y'all have about administrative issues at all, or the test? I think I put the answers to the test online. I built that into either the exam itself, or I put it in a separate location where here's our test answers. But I might be thinking of the other class. And so, any questions about administrative things?
this is less of a question about administrative things and more. I just wanted to let you know or not you, but my group member, Mary, I sent you a direct message in the chat, just so that we could get in contact with each other for the labs. Thank you.
Okay,
Yeah,
thank you so
appreciate
much.
that. Yeah, and using the chat, I will often see a little thing that says, "Oh, someone has left the chat," but I didn't see that, and so I guess send it to everyone or just me if you would like me to be able to see it. Yeah, so yeah, thank you. Definitely clearing things up is good. And then what about subject matter questions from either chapter 4 or 5? Sequential and adjusted sums of squares are important to be comfortable with. And one thing we found in chapter 5 is if you have a properly designed experiment with balance or any properly designed experiment with orthogonality, I guess balance always gives you orthogonality, but orthogonality essentially means I can't tell you based on information about one factor, the level that you're at, what level the other factor is at. Like I can't tell you based on, oh, you're in the southwest corner of the field. So yeah, you're more likely to have received treatment A than treatment B. No, balance would not allow that, and orthogonality doesn't allow that. And if you have an orthogonal design, okay, adjusted and sequential sums of squares are the same, and we love that feature. Any questions on any of that?
I had a quick question.
Sure.
I'm having kind of a hard time understanding why it matters sometimes in JMP. Like what you had mentioned, excuse me, putting certain variables in like a certain order.
Okay, so great question. I'll tell you if, yeah, if you want to use sequential sums of squares, then it implies there's an order, like a first variable, then the second, then the third, then the fourth. And so if there's ever a question where you think, aha, I want to control for these other x's, but not those, before answering a question about this x, then you make sure that the ones you want to control for are listed before the variable you want to test for, controlling for the sum, but not necessarily the others. Those would be listed later. So sequential sums of squares will do that. Now, two other things for follow-up. One of those two things is rarely do we really use sequential sums of squares. It's just pretty rare. And two, the situations where we're going to naturally want to use sequential sums of squares are going to come up like actually soon, like in chapter 7. And then again, when we talk about the partial F test right before the midterm. We've defined so far, but we haven't really sort of said, oh, yeah, sequential, you need it. So, Isabella, the reason why we use sequential, define it already, is basically say, oh, that gives us the definition of adjusted sums of squares. Controlling for all of the other x's taken as fixed. Does this x seem to matter? So, did I address the question that you had, or you want to rephrase?
No, that's perfect. Thank you.
Yeah, it's the thing that we have to do to get to the method we use. And we will rely on sequential sums of squares later on. I'll just say typically, and we'll emphasize this later on, typically the things we care about most you would put earlier, but it doesn't really matter if you're going to use adjusted sums of squares. And typically we're not going to use sequential. But if there are complex model terms, we would want to typically have them listed later. Our book calls that marginality, but we haven't really emphasized that just yet. Okay, any other questions on anything subject matter wise? Okay, so what I would like to do is to sort of jump in and move forward into chapter 6. Now, due to the nature of summer term and 2 classes per day and stuff like this, I'm just going to say I wouldn't be surprised if we finish up this class session a little on the early side, and I would not be unhappy about that. If we do, I would not be surprised. For the lab today, the week 3B lab, that's where the bulk of the learning, I think, takes place. Now, some of you are really solid on algebra and can sort of just go ahead and say, got it, got it, got it. Okay, no problem. Moving forward, let's get on to the next topic. But if you're not in that category, I'm going to say today we'll still go slow, no big deal, and we'll still finish early, but you will probably have some additional questions tomorrow. And that's great. It's a good idea to sort of show up with those additional questions. Okay. So what I'd like to do is to sort of move forward and just say we have this belief that you could have categorical and quantitative variables both in an analysis. We looked at an example where we had income as the quantitative variable and whether how a country was OPEC or industrialized, if you will, the country type was categorical. And shoot, let's just even go ahead and do a little circling of something here. Yeah, our variable, our I guess word equation basically says your lifespan depends on whether you are in an industrialized country or not, and it also depends on your I guess income. Okay, so we're sort of thinking the quantitative variable itself gives us a slope, so we get a slope attached to income, but the categorical variable has an effect, and type has an effect. I'm gonna try this, see if it works really well. Okay, so I'm gonna move over here to the side to make an aside comment. It turns out if you have a categorical factor with exactly two different levels, you could call them 1 and 0 and literally fit a slope for that as well. But the slope with only x values of 1 and 0, if you will, indicator variables or dummy variables, it just mathematically works out the same as the way we're approaching it. I'm just if you have a 1, 0 variable or a variable that takes on only values of say 1 and 2 for male and female, I would probably fit it as categorical, but if you fit it as quantitative, you will get the exact same fit, no big deal. Okay, back here. Um, we got a model here where we claimed lifespan depends on income, slope, and country type. Oh, well, there's two different country types. We're going to get two different trend lines. The effect basically says you're going to have an impact on the intercept. Okay. And that's what we're going to see in class today. Okay. So maybe what we should do is sort of show you this example in greater detail. We've already done it a couple times, so it shouldn't be new at all. So income and life expectancy, I for income. There we go. Yep, that's bouncing. And I unfortunately have all that extra stuff that I don't want. And I've got these different countries, income and life expectancy. And that's where we were at. Okay, so good. So there's type of country, industrialized or OPEC. Okay, and secondarily, we have income, another variable, quantitative in this case. Life expectancy, quantitative response. Our response is always quantitative in its style. And maybe I'll just do that just so I can feel comfortable fitting everyone in and moving it over. Furthermore, some days I feel more OCD than others. Okay, so I've got my variables here off to the side, and if under analyze, we're going to fit model like before. Okay. What we did earlier is we said life expectancy depends on, well, the slopey thing, income, fit a regression line. We thought income was important. We put it in the model first. Later, income maybe wasn't important, but I'm just gonna say let's put in income first and then country type. And you learned last time if you have adjusted sums of scores, it doesn't matter which of the two you put in first. I click run. I'm going to ignore the things that seem to keep popping up and emphasize the things that, well, they keep popping up, but I want to look at them. And today, maybe it's this collection of individual analyses. So first off, we always seem to get, if GMP can pull it off inside of fit model, it says by default, here's what you get. We say there's a trend line for the industrialized countries, and that's the red trend line. And then another trend line for the OPEC countries. And here's the interesting thing. These two trend lines happen to be parallel, and you might naturally be thinking, but what if the data is saying they're not parallel? Well, tomorrow we'll look at how we could adjust our analysis to allow for a model that isn't parallel. I'm just saying there's an effect on the intercept of it being OPEC country, or an effect on the intercept of it being an industrialized country. Okay, so there's your plot. We like the plot. We remove the plot. R squared, we're doing pretty good. 85% of the variability of life expectancy could be explained by our variables. Our analysis of variance says between our two variables, income and life expectancy, at least one of them matters. This model utility test is what it's sometimes called, or the ANOVA for the regression analysis. The model utility test basically says there's some utility with our model. There isn't no utility. It's not nothing. Okay. So we're saying there's something going on there. We learned earlier that we have regression estimates for parameters. I'm going to jump over that for now. I'm going to emphasize effects test. These are adjusted sums of squares analysis. And if we had, shoot. And if we had indeed said, yeah, show me the sequential tests, if we put them in sequentially in order, income first, you'd say, yes, income is better than nothing. And if you already had income, would adding in country type be helpful? You say, yes, indeed it would. Yes, indeed, country type is helpful above and beyond the effective income. However, so adjusted sums of squares, if income is being tested, having already controlled for country type, I don't see a slope related to income if we already have an impact of country type. And this is like what we did 2 class sessions back. Okay, so looking at the effects tests here, we would say, yeah, the one matters, maybe the other doesn't. Let's get now into our parameter estimates. We see an intercept, yay, a slope of income, and interestingly enough, it has the same p-value as our income variable does here. It suggests this parameter estimate income test is a adjusted sums of squares analysis. It's controlling for the effective type, yeah? And interestingly enough, your p-value for type is the same in the effects test as it is for in your parameter estimates. If you ever have estimates corresponding to 1 degree of freedom tests, they should have identical p-values. We see that's true in both our cases. Let me tell you another little fun secret. If you have 1 degree of freedom effects tests, the corresponding slope test, it gives you a t ratio. If we take this t-value and square it, you get the F ratio. If you take the t-value here for income and square it, you get the F ratio. There's a direct relationship, a squaring relationship to get to an F ratio from a t-value for a 1 degree of freedom test. So we're saying at the end of the day, yes, income seems to maybe not matter if we already have country type, but country type definitely does matter. And our model here, I sort of, darn it. There we go. I think I got, oh, here's the regression plot. Perfect. And so here's the model that we had fit. Okay, that's the model that we had fit, and we were happy with it earlier. Still happy with this model. But what I want to do is pull this guy apart now and get after it in greater detail. And this equation downstairs basically is how I want to start to think about things now. And it basically says, okay, we've got an intercept, which is 58 in our case, but I'm going to write it in general B0. Okay, so I've got y hat is just B0 here plus a B1 times X, or yeah, times X. Well, that's a weird symbol. B1 times X, I guess I just wrote it that way. Plus then it's going to be one of 2 different things, either A, the effect of it being an industrialized country, or A, an effect of it being an OPEC country. Okay, so you pick one of the two. And because my model has a Y hat on the left-hand side, it is my predicted level of estimated lifespan based on a function of, well, just these other values, X, and which category you're in. Okay. And GMP tells us in our parameter estimates all of the values here. So I'm going to sort of move this down just so that way I have additional space to write. I would literally say my predicted life expectancy is equal to, and I'm going to write it out, 58.4. Now I'm rounding a lot compared to where you should probably be rounding if you were doing this yourself for points on a test or for your boss. Plus, I'm doing it with rounding just to make it clear. 0.00104, 0.00104 times then income. And then I'm going to add in one of two values. And the value I'm adding in is either a positive 9.45 or it's a negative 9.45. How do I determine which one I add in? If you're in an industrialized country, you add in a 9.45, you subtract out 9.45 if you are an OPEC country. Now, why do I know it's 9.45? In the lower right corner, it says 9.45 is the industrialized effect, if you will. And we said earlier, you know what? The sum of the two effects is 0. So if I know AI and AO sum to 0, and if I know one of them is 9.45, the other has to be negative 9.45. We can verify this under estimates with our, expand out the estimates. So the OPEC is a negative 9.45 in the same way the industrialized is a positive 9.45. So we sort of confirmed with our expanded estimates these two values. So I'm going to leave this over here off to the right for reference for later. And now I want to consider each of these two separate cases. And I'm going to go with industrialized in one color, and I'm going to go red for the industrialized countries, IND countries. Literally, I'd say Y hat is 58.4 plus 0.001041 times then income. Okay, I'm just copying it down from upstairs, but I'm now adding in a 9.45. Now I'm spotting that these two terms here don't have times income in them. Let's collect them together. Yeah, so you would say 58.4 plus 9.45. I'm going to call it, shoot, I should have not rounded so much earlier. I'm going to solve my problem. 58.42. And there we go. Okay, so 58.42 plus 9.45. Okay, 45. Plus then 0.00141 times income. And I guess I have to add 9.45 to 58.42. And I would hope that one of you could check me with my adding in my head. I get 60, darn it. I'm going to have like 67.87. Plus then 0.0100. I'm sorry, 0.001. Correct the error here. And correct the error over here by starting over. Okay, 0.0. You know, being OCD sometimes is okay because if it allows you to get it right, that's a good thing. So did I get the sum correctly? 67.87 is the sum of 58.42 plus 9.45. Did I get it right?
Yes, you did.
I'm so happy because sometimes I don't. Um, So essentially, I said earlier, the effect, that plus 9.45, the effect of it being an industrialized country is an effect on the intercept. We added that to the intercept to get a new intercept, the intercept corresponding to the industrialized countries. So in red here, we've got what happens if it's an industrialized country. So what happens if it's not an industrialized country? What if it's an OPEC country? I'm going to sort of erase some of the stuff in red. I'm going to maybe rewrite it up here, up top. Y hat for the industrialized countries, IND. Y hat is 67.87 plus then 0.00001041 times then income. And I'm going to go back and sort of redo this for the non-industrialized, for the OPEC countries, which means I want to get rid of all the red downstairs. And I'm going to go with dark blue, but verify that we have the same style result. It's just that we're going to, instead of adding in a positive 9.45, we're going to subtract out that 9.45, if you will. We're going to add in a negative 9.45. And eventually I will get all of those. Gosh, I was really close. Okay, so let's choose a different country, different color. And so for the OPEC countries, okay, I have a Y hat is 58.42, like before, plus 0.001041 times then income, minus then a 9.45, and that is the effect of it being an industrialized OPEC country, not industrialized. And again, we're going to say those are the things without income in them. I'm going to collect the terms. I'm going to have, well, 50.4 intercept that corresponds to the no information situation. We don't know whether it's an OPEC or an industrialized country, and we're thinking equally likely to be either of them. So that's the average intercept, if you will. And the OPEC intercept is moved down by 9.45 units from the no information intercept. And I've got 0.001041 times then income as my, well, slope times income. So again, I'm going to need a little bit of help here, calculation wise. 58.4, I guess 47 point, I don't know, 97.
48.97.
I was so close. I was perfectly right in my head. So thank you for correcting me. 48.97 plus then 0.001041 times then income. And so the idea that we have is there's an impact and effect on the intercept of which group you're in. You got two groups, you're going to have two different intercepts, one for each of those groups. So I'm going to do a quick save that, clear the screen, unless any of you has a question. Any questions before I clear the screen? Okay, let's clear that screen then. So let's go back over here. It's just something we could do. The lab walks you through doing this. Let's sort of summarize where we stand so far. If you've got one qualitative variable, you're fitting a slope. If you add, I guess if you have two qualitative variables, you're literally fitting a plane. We haven't talked about that, but we will more later. Three or more qualitative variables, it's literally hard to draw, but it is a hyperplane. And if you have a categorical variable, you're going to get one of each of the above for the number of levels. For example, you had these two different categories of country type. You get the OPEC, yeah, and then you get the industrialized. So two different trend lines, because we had one line, now we got two, because we added in that extra variable. So let's do one more example real quickly. I'm not going to walk all the way through the analysis, but I do want to show you the analysis. And this is a cool data set, if I can, darn it. I thought I had it available. So let's go there. You go. These are data on a variety of broccoli. Yeah, let's go with this guy. So these are a variety of broccoli plants that I guess a soils student in Cal Poly sort of was able to enroll a farmer in her senior project study. And it's sort of a cool thing. She tried planting different types of broccoli, and the three types are con or ink or sim. There's probably real names for them, but that's what they were in the data set. And she measured the stem diameter of each plant at a certain number of days since the plants were seeded. DSSS is days since seeding. And literally, she didn't seed it directly in the field. She seeded in a growth medium. And then after a certain amount of time in the growth medium, they were plugged out into the field. And then she went, like at 82 days, and she dug up some plants. At 81 days, so at different number of days since they were seeded, she dug up the plants and measured the stem diameter themselves. Okay. And for reasons that you already have seen a hint of, we wanted to straighten out the scatter plot. We're going to plot log stem diameter along the y-axis. Yeah. So log stem diameter as a function of days since seeding, but there's three different cultivars. My way of approaching that with Graph Builder is, well, we're thinking the log stem diameter. That's your response variable. It depends on the number of days since you've seeded the plant, and it looks like there's a trend. That's sort of an awkward situation, but ignore that one data point. That wiggly line is sort of unfortunate, but I'm gonna make it like straight, and that straight line looks pretty darn good to me. What about our cultivar variety? I'm gonna show that as a color at first, and it says, okay, there's the reds, the blues, and the greens, and I'm seeing the reds are largely riding a little below the trend line. The below. If there is a trend line, a single trend line, there's a systematic problem that the blue data points, the con variety broccolis, they have stem diameters or log stem diameters that are larger. And the green, I'm sorry, the red at least tend to be below that trend line. So the trend line isn't really great. Maybe there should be different trend lines for the different groups. If instead of as a color, you say, let's make it an overlay, it says, let's do the picture with different colors for the different cultivars, and we'll draw in the trend line for each different group. Now, you're sort of thinking red and blue, they look parallel. Green's a little bit steeper, but certainly below the blue. We're allowing for the red and the blue intercept to be different from each other. So there's a hint in the graph, okay, that we should fix a problem. Let's go ahead and do the model that would tackle that problem. Okay, log stem diameter is allowed to depend on the days since seeding. Oh, and then also maybe different cultivars have different typical stem diameters. I click run. And we see, again, all the things are produced for us that we don't need. Fine. But it looks as though the blues and greens, we unfortunately changed colors between this situation and this situation. Notice a con was a blue, now it's red. That's frustrating. Ink was red, now it's green. They all change color. That's annoying. I'm going to get rid of the original. What we just fit was 1, 2, 3 trend lines with 1, 2, 3 different intercepts. And literally, I guess I have in my summary of fit, I'm saying, yeah, we're doing pretty well. At least one of these factors seems to matter. If I go down to effects test where we're saying controlling for cultivar, does stem diameter or days since seeding matter? Yes, it does. And controlling since for days since seeding, does cultivar make a difference? We'd say yes, it does. each of the two variables on the right-hand side in our word equations seem to matter. So what about this set of parameter estimates? That's not telling the whole story. It tells us the cultivar con effect, the effect on the intercept, the cultivar inc effect on the intercept, and there's got to be three effects because there's three different groups. There's also the sim and the sim effect plus these other two estimated effects. The sum of all three of them has to be 0, and one's about 0.2, one's about 0.1 negative. The other one should be about 0.1 negative, like negative 0.09 is my bet. If we turn on estimates, expanded estimates, we can literally get that parameter estimate confirmed or verified. And so indeed, we said about a 0.09 negative. It is 0.09 negative, and the 0.08 negative, I'm sorry, plus the 0.116. They add up. Yep. All three add to 0. Yay. So what do we see? The real shot uh, uh, is you have difference. Toss the categorical variable in there, and you will draw one trend line for each group. And that will be, in chapter 6, parallel. We're going to see in 7 how they aren't required to be parallel and how we can even test to see if they are statistically significantly non-parallel. But that's a topic for a different day. And I'm going to just sort of pause here and answer any questions you have. And if there aren't any in about a minute, I'm certainly going to stop the recording and then call it a day. Any questions?
Thank you.
So when I said a minute, I totally lied. Okay, stopping the sharing. I'm stopping the recording. We will see you all tomorrow when we'll talk about lines that are not necessarily parallel. We'll see you then. Bye-bye.